It is without a doubt the first celestial body outside of our solar system to reach the interplanetary zone. The movement is excessively quick, excessively unpredictable for the draw of the sun to keep up. It was the first thing we saw from interstellar space, and when it arrived, there was a lot of excitement, rumors, and scientific research about it. People have been investigating space for a really long time, sending tests to the furthest reaches of the planetary group and utilizing telescopes to see things that the unaided eye can't. Yet, when Oumuamua was found, everything changed. The James Webb Space Telescope has now revealed the first true image of this cosmic enigma, revealing details that no one else has ever seen. This mysterious visitor from space has been studied in recent years. Come along with us as we investigate this image further to discover how Oumuamua shook the foundations of our comprehension of the universe. Without a doubt, Oumuamua is extraordinary and captivating. Because it had never been seen before, it emerges from space's depths, confirming its existence and drawing global attention. This long, stogie-molded guest to our planetary group came from a district of room past our own, a surprising interstellar test that meanders the limitlessness of the universe on a little excursion. We have never seen anything like it before, with a shape similar to a thin cigar or what some people refer to as an infinite needle. The astonishing revelation of Oumuamua was made on October 19, 2017, when the Container Stars 1 telescope in Hawaii checked the night sky and found the presence of this uncommon article. It was a notable occasion, as it was whenever space experts first had seen whatever came from outside our nearby planet group. The astounding thing is that everything about Oumuamua arrived at our nearby planet group and went directly to Earth. The rise of Oumuamua is perhaps of the greatest galactic occasion in ongoing memory, and it's vital to dig further on the grounds that it appears to hold the way to opening the secrets of our grandiose climate. Affirmation of Oumuamua's interstellar beginning was not a question of scurry, but rather of cautious and intensive examination. From the outset, the item was believed to be only a space rock, one of the many kinds of room shakes that occupy our planetary group. In any case, as cosmologists accumulated more data, they understood that Oumuamua was nothing similar to a normal space rock. Its circle, speed, and strange shape showed that it was not local to our nearby planet group, but rather a guest from a far-off star framework, tossed into space by a grandiose occasion and on a direction that brought it near the sun. As this strange visitor, unlike any other asteroids or comets we had ever seen, began to take shape, the world's attention was focused on it. The elongated form and erratic movement of Oumuamua defied conventional classification. Its surface is more reflective than expected, suggesting a composition unlike any other in the solar system, and it rotates like a bottle in the ocean. A few hypotheses started to arise. Was it a section of a planet isolated from its parent framework by a horrendous impact, or a part of a comet that had lost its frosty external layers after some time in the chilly profundities of the universe? Or then again, might it at any point be something totally different? An outsider relic, maybe an unwanted rocket floating in space? These inquiries, however enticing, can't be replied without additional information. Researchers expected to move quickly as Oumuamua was going at extraordinary paces, quicker than any shuttle we've at any point sent off, and was on a way that would before long remove it from our planetary group for eternity. The unexpected disclosure was that cosmologists had half a month to concentrate on this interstellar guest before it disappeared into the haziness of room, conceivably gone forever. Astronomers gathered their resources for this challenge. Groups from Hawaii, Chile, and Spain zeroed in on Oumuamua, gathering however much information as could reasonably be expected as quickly as possible. The Container Stars 1 telescope, which was quick to notice the article's situation and speed, gave basic beginning information, while different spectators contributed extra pictures and perceptions that addressed the secret of its starting point. One of the most intriguing qualities of Oumuamua is its brightness. As it travels through space, its splendor changes emphatically, showing that it is significantly longer than it is wide. This is as opposed to regular space rocks or comets, which are for the most part round or sporadic in shape. The progressions in splendor recommend that Oumuamua is turning, yet not easily and consistently. Instead, it appears to be tumbling and turning at random, a rare motion for celestial bodies that raises numerous questions about the forces it is subjected to. Oumuamua's color is also a mystery. It has a red appearance like numerous space rocks in the planetary group, yet its surface is surprisingly intelligent. This suggests that it may be coated with a material that is both reflective and resistant to harsh environments. A few scientists suggest that the item could be metallic, maybe the remaining parts of a bigger body obliterated by a vast occasion. Others recommend that Oumuamua could have been canvassed in carbon compounds from substance responses as it went through the interstellar medium. Scientists developed models to explain Oumuamua's origin and behavior as information continued to flow. It could be a planet or moon fragment ejected from its parent system by a close encounter with a larger object, such as a black hole or giant planet, according to one theory. This might account for its unusual rotational motion, elongated appearance, and high speed. One more hypothesis suggests that Oumuamua is a section of a bigger body destroyed by flowing powers while passing near a star, making it a sort of divine molecule tossed into space by the star's gravitational draw. Numerous questions remain unanswered in spite of these intriguing theories. For instance, even though Oumuamua was close to the Sun, it did not emit any cometary gases. When heated by the Sun, the majority of comets release gas and dust plumes that form a glowing halo and a tail that extends for millions of miles. However, Oumuamua has not displayed any of these characteristics, indicating that it is not only a comet but also something entirely different. The secret extends as researchers dissect the way of Oumuamua as it gets away from the Sun. Its movement appears to go astray based on what is generally anticipated in view of the draw of the Sun and the planets. The deviation is little yet huge, showing that an extra power was following up on the article. One clarification is that Oumuamua was dependent upon the Yarkovsky impact, a peculiarity where the Sun warms one side of an article, making it transmit infrared radiation and produce a little however quantifiable power. However, in order for Oumuamua's acceleration to be explained by the Yarkovsky effect, the material must be extremely light and thin, more like a sheet of paper than a solid rock. Because of this, some scientists came up with a more bizarre theory that Oumuamua might be made of something, like a light sail made by an advanced civilization. A light sail is a sort of space apparatus that utilizes the tension of daylight to drive itself, and a few specialists recommended that Oumuamua's prolonged shape and surprising speed increase could be reliable with such a plan. This thought, however exceptionally speculative, caught the creative mind of the general population and ignited restored interest in the quest for extraterrestrial knowledge. The James Webb Space Telescope, JWST, was poised to play a crucial role in the investigation as the debate over Oumuamua's true nature raged on. With its powerful infrared capabilities, JWST is ideal for studying far-off and dim objects. The composition and structure of Oumuamua can be better understood thanks to its capacity to detect heat signatures. Scientists can now examine Oumuamua in greater depth and uncover previously unknown details thanks to the telescope's extreme sensitivity and resolution. JWST's capacity to gather and examine infrared light is a significant apparatus for concentrating on interstellar items like Oumuamua. Astronomers are able to see through the gloomy clouds that surround celestial bodies because infrared light is less affected by gas and dust than visible light. This makes JWST an important asset for investigating the external districts of the nearby planet group and then some with cutting-edge instruments fit for recognizing faint warm marks from objects that are excessively old, far off, or soon to be identified by different telescopes.